Hi there, in this video I'm going to do a revision question on differential equations. So let's take a look at the question. Question 3. Solve the following first order linear differential equations, and in part B we need to solve this equation dy over dx plus y cot x equals cosec x. So let's think about the method. Let's get back to the paper and pen. Now, first of all, the question did say that it's a first order linear differential equation. Now, if you're unaware of what a first order linear differential equation looks like, it's any equation of the type dy over dx plus px into y is equal to q of x. And px and qx are both functions involving x only. So if you have an equation of this type, you have a first order linear differential equation. So FOLDE stands for first order linear differential equation. Now, if you're unaware of the method, let's go to the screenshot explaining the method in detail. So step number 1 of the method is to write the given differential equation in standard form, and standard form means we need to make sure that the coefficient of dy over dx is equal to 1. So if the coefficient of dy over dx is equal to 1, that means that your equation is in standard form. Back to the paper and pen. Now, our equation given is in standard form, so it is in standard form. Reason being is that the coefficient of dy over dx is already 1. So for step number 1, therefore I'm going to leave it as dy over dx plus y cot x is equal to cosec x. So just to recap, the coefficient of dy over dx is already 1 in our equation, so that makes this equation in standard form. So let me make a note in red. So coefficient of dy over dx is equal to 1. So that implies SF. SF means standard form. Now, whenever I do questions of this type, I like to name my standard form equations. So I'm going to name this star. So star is the equation which is in standard form. Now, this is nicely going to take us to step number 2. So back to the screenshot. Step number 2 calculates the integrating factor IF. And to work out the integrating factor, there is a formula, IF, the integrating factor, and that is e to the power, the integration of px with respect to x. Now, I've made a note that if the power, when it comes to integrating that term, contains ln, go one extra stage and use the result e to the ln a equals a to simplify IF further. Back to the paper and pen. Now, with all that in mind, Rpx is the coefficient of y, so the coefficient of y is plus cot x. So px is plus cot x. Let's make a note of that. Let's use the formula for the integrating factor. So it's e to the power integration of px with respect to x. So it's e to the power integration of, now px as noted is plus cot x, and when I integrate cot x with respect to x, it's ln sine x. Now if we go back to the screenshots quickly, now remember I did say that if the power contains ln, use the result e to the ln a equals a to simplify IF further. Back to the paper and pen. Now our power contains ln, so it's e to the ln sine x. So let's use the result and write that as sine x. So remember, since e to the ln a is a, that would make e to the ln sine x sine x. So that completes step number 2. Now back to the screenshot. Step number 3, multiply the equation in standard form, which is star, by the integrating factor IF. And take note that you need to multiply every single term in your equation by IF. Back to the paper and pen. So here is step number 3. So our standard form equation is star. So here is star. Let's multiply every single term by sine x, which is if. So multiply star by if. Let's do that. Sine x times dy over dx is sine x dy over dx. Sine x times y cot x, let me just leave it as y cot x sine x. So let me just leave that as that for now. That is equal to cosec x times sine x, which is cosec x sine x. I didn't simplify the left-hand term. You'll see why when we go to step number 4. So with step number 4, and let's go back to the screenshot. Step number 4 is, by the product rule, the left-hand side of the equation can always be rewritten as d by dx of ify. So this is always the case when it comes to this step. So back to the paper and pen. So the reason why I didn't simplify this further is because, regardless of the simplification, this whole term is always d by dx of ify. So you can always rewrite it in this way. So let's implement this. So we have d by dx, if is sine x, into y, and that is equal to the right hand term, which reads cosec x sine x. Now this is no trick. Believe it or not, if you differentiate this term, you should get this entire left-hand term as a result. So you can try that as a side calculation if you want. Now, moving on from there, I can simplify this term on the right, because remember, cosec is the reciprocal of sine. So 1 over sine x, remember, is cosec x. And with that in mind, I can cancel the sine x with the sine x on top, giving us 1 on the right hand side. So that takes care of step number 4. So let's go back to the screenshot. Step number 5 is integrate both sides. So we need to integrate the left hand side. We also need to integrate the right hand side. Back to the paper and pen. So here is step number 5. So in step number 5, let me just make a note. Integrate both sides. Now, if we integrate the left-hand term, if you integrate something that you differentiate, you're going to end up with the term here, which is sine x, y in this case. However, we need to integrate 1 on the right-hand side with respect to x. So let's complete the question. So we have sine x into y on the left. And if we integrate 1 with respect to x, it's x plus c. So this should be the solution to question 3 part B. Now, if you're not familiar, if you're not sure about the method still, I have created videos explaining the method step by step, along with additional examples, and I'll provide links to these videos in the description below. However, if you did enjoy the video, if you did find the video helpful, a like rating is very much appreciated. Do plenty of practice related exercises, and I hope to see you again. Thank you.